In this video, we're going to go over investigation 4D. So in this investigation, we've learned two things. One is how to solve inequality by using algebra and also a graph. And the second thing we've learned is to learn the line of best fit, how to draw a line of best fit. So let's take a look at first examples. For example, let's say we have absolute value of 2x plus 1 is greater than 5. So first thing we do is to split this into two graphs so that we can draw it. And y equals 5. And now we're going to graph these two things. As you know, absolute value graph will be V-shape, like that. And this y equals 5 graph will be flat line. And the question is asking, when is this absolute value of graph of absolute value is greater than this 5? So we are looking at the zone that's this statement is true. So so we have two intersections, and we have three zones. So this is the first zones, and if you describe that in number line, here's another second intersecting point. So this V graph is higher than this line when before the first intersection and after the intersection. So we are talking about these two zones. Okay. So the second, and then the next thing we have to do is to find what is those intersecting points. Then if we can find out those intersecting points, we'll be able to have a specific examples. So we're going to solve that. 2x plus 1 absolute value of equals 5. We can find out this intersecting points by solving equation, because intersection satisfies the solutions of this, and there are two numbers can go in there. So if you think about the blank box, for example, what number can go in there? It is +5 and -5. Okay. Then an original example is 2x plus 1. So we have 2x plus 1 can either be +5 or -5. Just simply solve this problem. Subtract 1 from both sides, so we have 2x equals 4, so x equals 2. And then solve this one, subtract 1 from both sides, so we have 2x equals -6, so x equals -3. So this point, the first intersection is -3, and the second intersection is 2. And the zones, so as long as we are choosing less than 3 or more than 3. So we use open circle because we don't have equal sign here. It's just a simple inequality sign. So if we write this in the symbols, we have we can choose any number we want to, as long as it is less than -3, or we can also choose any number as long as it's greater than 2. So that's what we did for the first one. Second thing we've learned is the line of best fit. So for example, let's say we have some data set, we have negative 1, 1, 4, 5, 0. 3, that's the input. And the output is 3.5, 4, 5.5, and 4, 2, negative 1. So if we graph that, we would have negative 1 and 3.5, so 1, 2, 3, and the 5 right there, somewhere over there. And we have 1 and 4, so 1, 2, 3, 4. 4 and 5.5, so 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3, 4, 5. And a 5 and 4, so that's somewhere over here. 0 and 2, 1, 2. Somewhere over there. That looks a little awful, but you know what I'm doing. So last one is 3 and negative 1, so it's 1, 2, 3, and negative 1. So this is pretty scattered. This looks like it's spread out all over the place. So first thing we have to find is x bar and a y bar. That's the balance point. How do we find these values? It's very simple. X bar is the value of x input. So let's add on my calculator. Let me take out my calculator. Where's my calculator? Right there. Okay. So we have negative 1 plus 1 plus 4 plus 5 plus 0 plus 3. So that's 12. 12 divided by 2. 12 divided by 6, because we have 6 numbers. Man, I didn't need a calculator. So x bar is 2. Y bar is, add these together, so let me just use my head. This gives us 9, and 4, 4, 2 is 10. 9, 10, and 11, and this is subtract 1, so it's 18. 18 divided by 6 is 3. So our balance point is 2 and 3. So let me use a different color. So it's 2 and 3, so it's 1, 2, and 1, 2, 3. So this is the balance point. And the line of best fit must pass through this point, which is the balance point. So as long as that hits balance point and it looks like it fits, then that's the line of best fit. Okay, so let's ignore this guy. This looks like an outlier. This is some error. It's way off. So let's ignore that. We can ignore the outliers like that. And line goes like that, right? So we're gonna have to find the equation of this. So as you know, equation is in the format of y minus y sub 1 equals m times x minus x sub 1, right? That comes from the slope formula, which is m equals second y minus first y over first x, second x minus first x, right? And then multiply these, and then we get this formula. So we're going to use this formula. Y sub 1 in this case is 3. So we have y minus 3 equals m times x minus x sub 1. In this case it's 2. All we have to do is to find this m. M looks like, okay, it looks like it goes up 1 and it goes 2 over. So the slope is, we can kind of approximate, slope is a half, goes 1 up and go 2 over. So now we can write the complete equation, which is y minus 3 equals half times x minus 2. So that is the equation of line of best fit of this.